All right, so one of the more difficult transformations that we cover is rotations. Rotations is a visual thing that you kind of have to see, and we're going to go through examples of actual seeing it in class, but what I want to put the video out for today is using the rules and just rotating an object around the origin on 180 degrees, 90 degrees, clockwise and counterclockwise, and then also doing some 270 and counterclockwise and clockwise rotations of just coordinates. So some of the rules that we need to kind of go through first before we get started, and the board is already acting its beautiful self today. So one of the first rules to look at is, early on we talked about the coordinate plane itself and how it's set up. So it's broken into 4 parts. You have your 4 quadrants, being quadrant 1, quadrant 2, quadrant 3, quadrant 4, okay? So within these quadrants, we still have our x and our y axis that run all the way through it. And the nice thing about this is on the right-hand side, you have a positive. You're going to be positive numbers, and on the other side, you're going to be negative. Down below on the y-axis, if you go below the origin, which is our center point right there, it's going to be negative, and on the top side, it's going to be positive. Now, some of the things that we just want to make sure that everyone remembers. In quadrant 1, if you have coordinates in quadrant 1, your x and y are both positive, okay? In quadrant 2, your x and y, your x is negative and your y is going to be positive. So these are all things that we're going to need as we go on. Okay, moving down to quadrant number 3, we have our x and y. They are both negative in quadrant number 3. And then the final quadrant, quadrant number 4, our x and y, our y is negative, and our x value is going to be positive, okay? So how does this all work? If we're rotating 180 degrees, clear this off here, or try this again. If we're rotating something 180 degrees around the origin, and our coordinate was x and y, when rotated 180 degrees, our x and y will, if they were both positive, will become both negative. So this one's probably the simplest one. So we just have to look at if the coordinates were either positive or negative before we did it, and then if we rotate 180 degrees, the only thing that changes is you need to add a negative to the x value or add a negative to the y value. All right, so that is the easy one. The one that gets a little bit more difficult is now when we get into rotating 90 degrees or 270 degrees. When we rotate these, our original x and y, in this case, we're going to just keep them both positive. When they rotate, the values actually flip. And what I mean is, normally when we write an ordered pair, we'll have our x and our y. But our new x over here, our new x here, is actually going to be our original y. And our new y is actually going to be our original x. Now, what value happens in front of it, if it's positive or negative, depends on where you started and where you rotated, which then goes back to understanding our coordinate plane over here. And that's the reason that in class that I put a big emphasis on making sure that you understand which quadrant's positive or negative. So say we rotated this aspect 90 degrees clockwise. So we're rotating it clockwise. If you look at these two values, these are both positive values, okay? So if I go over to my little board over here and I'm rotating it 90 degrees, and it's clockwise would rotate it to would be the right in a clockwise fashion. And I think I even in class wrote an old school clock on like the outside with all our numbers here, and it's getting a little messy here, but just kind of work with me, but we're rotating that way. So if we're rotating 90 degrees clockwise and we're in quadrant 1, we would move 1 quadrant clockwise, we would end up in quadrant number 4. So quadrant number 4, our x's are going to be positive and our y's are going to be negative. So when we rotate to positive coordinates to a 270 or 190 degrees, depending on which way we go, whatever quadrant it ends up in is going to give us our new coordinate. So in this case, remember this x, or the y is now going to be our new x. So pen's up here. Okay, so this flipped, so our new x value, which is the number that was for y, in this case is going to be positive, and my new y, because we're in quadrant 4, will be negative. Okay, and I'm going to put that to show with actually using numbers. But that's kind of the gist of it. So our two rules are the 180 and 90 degrees that we're going to be looking at. And then also we have to remember clockwise and counterclockwise. And I might actually have to do a video a little bit later on about that, just to make sure that we have that understanding of what's going on. So let's take a look at an actual problem and how this would break down. Okay, so here we have a problem that asks us to rotate a triangle Q 4, 5, 4, 0, and 1, 0, 90 degrees counterclockwise around the origin. Okay, so just for my benefit here, and go right here, get my pens back, get a smaller line here so I can kind of draw some stuff over on the side. So we're going to put a little coordinate plane over here. I'm going to put plus plus for our first coordinate. This is going to be I don't know why that always changes on me, but this is going to be negative plus, and then negative negative, and down here we will be at plus negative for our x and y's. So that's our x, y, x, y, x, y, x, y. So I have this to kind of reference as we go back. So first thing I'm going to do is I'm going to rewrite our coordinates down. And I like to rewrite them down and then work vertically down from there. So we're going to go 4, 5 was our original. And then we're going to go 4, 0. And then we're going to go 1, 0. All right, so here's how this works. So the first step I'm going to do, if I'm going to be rotating this 90 degrees, in this case counterclockwise is what they tell us right here. Going back to the rule, I stated that when rotating 90 degrees, the original x and y, when rotated, flip. So their new values, even though I'm writing it as yx, is really in the xy format. So how does that work? So if you take a look at it, our original x was 4, our original y was 5. When rotated 90 degrees, that becomes 5 and now 4. So you're just flipping the two numbers. Same thing, this would be now 0, 4. And our last one is going to be, whoops, got ahead of myself there. Is going to be 0, 1. Okay? All right, so where did this start? If you take a look, all the original numbers were positive, 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 positive. So this is actually an easy one. We're looking at our coordinate plane, and all of our positive positives start in quadrant number 1. If we're going to rotate counterclockwise, which means we're going in reverse clock fashion, we're rotating back to quadrant number 2. And in quadrant number 2, our x value is going to be negative and our y value is going to be positive. So now we got these numbers changed over. Our original x is now going to be our new y, and our new y is going to be our new x, which was shown here. Now what we do then is just put the correct symbol in front of it, in this case positive or negative. So being in quadrant number 2, we would have negative number. Well, 0 doesn't need to be a negative, and so does that one. So that would be our answer for a 90-degree rotation of counterclockwise of this triangle from one to the other. And then when drawn out, you would see the rotation makes a 90-degree angle through the origin to each one of the points from the original points. Now rotating 180 degrees, and I know it says around vertice S, but we're going to change that, and we're just going to rotate it around the origin. So we take care of that. And in class, we'll talk about rotating around an actual vertice. That's really not going to be the main focus. We're going to explain it to you. We'll practice a couple of them, but our main emphasis is making sure that you understand how to get through, rotate stuff around the origin. So move this up here, and I want to get these coordinates written down first. So we had, oh, we're all over the place here now. Okay, we had 4, 5 was our original, and 4, 0, and 1, 0 are our originals. And I'm going to erase some of this other stuff so it's not going to cause it to be a little bit of a mess here for us. Bigger eraser here. Now, following the rule that we had put together for 180 degrees, in a rotation of 180 degrees, your x and y's stay in their same spot. Okay, so the numbers are actually going to stay the same, but if they're both positive, now they become both negative, so it's rotating all the way through. So in this case, if we take a look at our originals, all positive, putting them in the quadrant number 1 up here again, okay? 180 degrees would rotate it all the way, and 100 degrees clockwise or counterclockwise doesn't matter. You're going to end up in the same one, as you can see. In this case, they're going to be across from it, and they're all going to be negative. So all we have to do then to change this, to put this 180-degree rotation, is just put a negative in front of the values that need a negative. In this case, you don't need to put -0, just leave it as 0. So this would be a 180-degree rotation of that triangle around the origin, not the vertex S. Erase that out again, but we're looking at around the origin. Okay? So that is kind of the skinny of rotation. It kind of probably went a little fast, but we'll cover them in class multiple times. And once again, the video is just to help refresh if we forgot stuff, if we're at home and need to wrap up some things. So hopefully this helps you out.